when we moved from monolithic architecture to microservice architecture, we solved a lot of issues like lack of reusability, lack of scalability, large code bases, just to name a few issues, right? But we soon realized that microservice architecture has its own set of problems, the biggest and most consequential of which is communication. By the way, a service mesh manages communication between microservices. In a typical microservice, the first and foremost thing is its business logic or its core functionality. There are also various auxiliary logics, like there needs to be a configuration for all the endpoints that a particular microservice needs to communicate with, whether it is to receive or send data. So when a new microservice is added to the cluster, all the other microservices which need to communicate with this new microservice need to know about it. Next, there is security. Generally, the intra-cluster communication occurs over unsecured channels like HTTP. So if a rogue element somehow manages to get inside the cluster, then it can do whatever it wants. So there also needs to be a security logic inside each microservice. We don't live in an ideal world where the communication gets established on the first try and we don't lose this connection while we are performing necessary activities. So there needs to be a retry logic which specifies the behavior when the communication is lost or the other entity which we need to communicate with is not reachable. Then you want to track the health and monitor the performance of the microservice, like number of requests received, time required to send the request, so that you can perform optimization and increase the efficiency of your system. As you can see, there is a lot more inside a microservice than meets the eye. There's a lot more auxiliary code than the core business logic. So this increases the size and complexity of the microservice. Before we go into the solution for these issues, if you like my work and would like to just buy me a coffee, you can visit buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Moving on. I'm assuming that you know about sidecar containers. If not, a sidecar container is a container which helps the main container by performing tasks which will enhance the capabilities of the main container. Coming back to the issue in hand, one solution can be to separate the core business logic and the auxiliary logics like security, retry logic, etc. that I have discussed before, by packaging this auxiliary logic and forming a sidecar container. So now the developers can focus more on the core business logic rather than worrying about these additional logics that they need to take care of. So they can spend a lot more time on core business logic. Going one step further, we can use an open source service which takes care of these additional logics as a sidecar proxy. One good thing about service mesh is that it can inject this proxy into the microservice pods without modifying the microservice YAML files. Istio is one of the implementations of this service mesh pattern. Istio uses an extended version of the Envoy proxy, which is an open source project, as the sidecar proxy, which we talked about earlier. Envoy's built-in features include dynamic service discovery. This is adding a new microservice to the list of endpoints. Load balancing, TLS termination, health checks, staged rollouts with percentage-based traffic split, fault injection, rich metrics, and circuit breakers, just to name a few. Traffic splitting is splitting traffic between existing and newer versions so that we can see if there's any undetected bug in the new version. Our job is to write the CRDs, which is custom resource definitions. Istio converts high-level routing rules that control traffic behavior into Envoy-specific configurations and propagates them to the sidecars at runtime. Istio security enables strong service-to-service and end-user authentication with built-in identity and credential management. Istio acts as a certificate authority and generates certificates to allow secure MTLS communication in the data plane. When it comes to inter-service communication, we use virtual services and destination rules. Virtual services let you configure how requests are routed to a service within Istio service mesh. We may need to use multiple virtual services or none, depending upon the use case. Virtual services are like routing tables inside a router. Destination rules are applied after virtual service rules are evaluated. You use destination rules to configure what happens to traffic for that destination. So we write these CRDs, which are converted into Envoy-specific configuration and propagated into the sidecar proxy. These are injected by Istio. Proxies can now use these configurations for communicating with each other. As I have said earlier, Istio gathers the metrics and telemetry data from these Envoy proxies, which can be later used by monitoring server like Prometheus. Istio also acts as a ingress gateway. If you don't know what ingress is, you can refer to episode 7 of this podcast. According to Red Hat, over time, data made visible by service mesh can be applied to rules for inter-service communication, resulting in more efficient and reliable service requests. Rules can also be written to determine the optimal wait time before retrying for a service. This ensures that the system does not become overburdened by unnecessary retries. So this was my small episode on Istio. If you like this and like I already said, if you would like to buy me a coffee, you can visit buymeacoffee.com/CHINTU and just buy me a coffee. I'll see you in the next episode. Thanks.
If you like this episode, please consider following us wherever you hear your podcasts.